and welcome back. And now we are moving on to our next speaker from the University of Windsor, Canada, Mair Durrani. As an expert in civil engineering, he will show us how he and Chris Lee used R, Python, and Shiny to create a live map of a road network with real-time car location updates from a driving simulator. So buckle up for an exciting ride into the realm of dynamic visualization. Mair, I'm passing the mic to you.
Thank you. Hello, everyone. My name is Umair Divani, and today I'm going to tell you a story from about 2 years ago when I was a postdoc at University of Windsor in the civil engineering department. I was working under Dr. Chrisley at the time. I'm not at University of Windsor now. I am now at the Prasad Group as a junior data scientist. So this story is about creating a apparently impossible problem for us, where we used Shiny app to create a live map using the car position data that was obtained from a driving simulator in our lab. So Dr. Chris Lee was the lead investigator of this project, and this was with the Ministry of Transportation in Ontario in Canada. And Chris Lee is a professor in civil engineering. At the time, as I said, I was a postdoc working in the lab. The main reason for this project was distracted driving, a broader topic, which, as we all know, is a big problem. And distracted driving in Ontario, particularly, is a rising issue. In 2020, there were about 14% of all fatalities that were happening due to inattentive driving as a factor. So, Ministry of Transportation in Ontario, they were concerned about researching why that happens, what are the different factors. And this was the proposed topic that Dr. Lee created, mitigating distracted driving based on understanding of drivers' personality, motivational, and mobile phone dependency characteristics. And one advantage that we had in the lab of conducting this experiment and this project was a driving simulator. So this is what a driving simulator looks like. So what you see here is the participant who is entering on a highway and driving along the trucks. So this driving simulator generates car position data, the position of the car that is being driven by this participant. And the goal of the Shiny app was to create something that could be used alongside this driving simulator that was on a touchscreen laptop. It should be connected to the driving simulator so that we could harness the data from the simulator. Is able to play music and also able to use a map to navigate. Before I show you how we solve this problem, this is what the final product looked like. We have again that driving simulator. In this example, the participant is in a parking spot, and you can see that laptop attached with the driving simulator running a Shiny app. This is a close-up of the same app, and you can see the parking spots visible in the dashboard. This is a demo of how the app looked like when we were running it in the lab. So the challenge was to use an existing driving simulator and then get the car position data and put a laptop here or any touchscreen device that the driver could use as a navigation device and also should be able to play music on it. And we were then finding out using data how distracted drivers were, how much time they were spending on navigation, whether it was helpful or distracting while they were driving. So driving simulator generated the car position data, and there was a computer attached to that simulator which could receive the car position data. The documentation that was available to us was with Python, although R can also use the socket library, the socket functionality to get the data from driving simulator. The documentation was not available for R, it was available for Python, and since my background is not in computer networking, I found it easy to use Python. So the first challenge here was, how do I get the car position data and then send it to the laptop where I will be running the Shiny app? Remember, the data is generated from the simulator received by Python. So I can attach an Ethernet cable, and this is how the car position data is generated and received in Python. So the main thing here to look at is this fields object. The fields object represents the x and y coordinates of the car position. So the question is how to send the car position data from the driving simulator PC to the laptop where I will be running the Shiny app. There was actually no need to do that because as long as you are on the same network, Shiny can be accessed on any device on that network. So what I needed to do was create a Shiny app, and then using a particular port and address, I can serve that Shiny app, which can be accessed by any device, particularly this laptop that I connected with the PC using an Ethernet cable. And when I visited this address in the laptop browser, the Shiny app could be accessed with the laptop. The advantage here was also that I could access the app on the main simulator PC as well. So while our participant was using the app on the laptop, I could also at my end, without the knowledge of the participant, run the app at my end on the PC and then see where they were. So this is what the current setup looked like. I could visit this address and then run the app, and it could be accessed easily on both PC as well as the attached laptop. But the next question was, if the data is generated with Python or received by Python socket, how do I get this data into R and essentially in Shiny to display it on the map? Now, there were several options at the time to create an app in Python as well. The most popular was Streamlit, but in 2022, Streamlit reactivity options were not as great as they are in Python. And I think they're still not as great. And there was no Shiny for Python. So I only knew how to use Shiny, and that was my only option. So I wanted to somehow send this data from Python, receive it in R, and then use it in Shiny. So the solution for that was in Redis. Redis is an in-memory data store. You can generate any process or processes, and let's say Python is getting the data and we push the data from Python to the Redis memory store, and then you can receive that data from the Redis store into R. To use Redis, there's no direct support on Windows, but you can install the Windows subsystem for Linux on Windows, and that would enable you to run Redis server. So I installed the Ubuntu operating system on it, and then installed the Redis server on Ubuntu. And this is the command that would essentially run a Redis server. Sudo service Redis server start. It will ask for a password of your Ubuntu account, and you enter it, and your server starts. Now it is ready to receive data. So within Python, I wanted to now send the data that was received from the driving simulator to Redis data store. Luckily, there is a Redis module in Python. I use that. And then using the Redis command, I then set up or connect it to the local host. The default port here is 6379 that Redis uses. By default, Redis uses 16 databases. You can use more if you want. In my case, we only wanted one database, so we use db equals to 0 here. And if you recall from the previous slide, the fields object is what creates or contains the x and y coordinates. I first converted into a dictionary and then into a pandas data frame. Now this data frame could be sent to the Redis store. So with the Redis module, I use the rpush command, give it a name, position, and converted the data frame to JSON. And now this JSON data was pushed to the Redis data store as the data was being generated. The data in this case was being generated every 1/60th of a second. Okay, so now data was in Redis. The next question was, how do I get this data from Redis into R and then use it in Shiny? So this is my code for the Shiny dashboard. At the time, BSLib was not at its current maturity level. So I was using Shiny dashboard, and R also has this Redux library that has this hi Redis command that would then let you connect connect R to the Redis data store. So in the Shiny app, I did that first. Next, I created a reactive timer, which you can change the value here. This is in milliseconds. You can change it to anything depending on how quickly you want to update the data. In this case, I'm using 0.005 seconds to update the data. So position data frame or list is created using this reactive expression, where the reactive expression is invalidated whenever this much time is elapsed. And then from within R, using the rpop command from the Redux library, I can get the data out of Redis into R. And since it is in JSON, I then convert it back into an R data structure, a list. And now that the data is in R, I can do anything with it. I can now use it in R. I can now use it in Shiny to update my map. So I get my X and Y position data from the position data structure that was created above. And then within the ggplot, I then updated my position using the reactive position object. So this shows a quick demo of what it looked like. Initially, you create the Redis store, you connect to it. And once the Redis store is ready, you run the Python commands, and it will start generating the data. So here I'm also printing it to show you the data generated every 1/60th of a second. On the R side, with the Shiny dashboard, I could use Shiny's own functionality to play music, as well as update the map as I showed in the previous slide on the maps side. So you can see that the position is changing in real time, almost in real time, as the driver drives. And I can also update the directions, turn left, continue straight, turn right, using this, something like Google Maps. So in conclusion, Redis data store can be very useful if you have multiple processes that are generating data and you want to receive data, just like multiple R processes or Python processes or any other language or process that is generating data. You can use Redis to connect the data between the two languages or processes and use them in your Shiny app as I showed here. So I've linked to some of the resources, the libraries in Python and R, and the slides and the app stores are also available on these links. Thank you.
Thank you, Mayur, for incredibly informative and insightful presentation. The racing gaming fans appreciated the visualization as well. We have only 1 minute left before we go on a break for the next speaker. So I don't want to leave you, just let you go without a question about the complexity of the real-time data integration from a driving simulator. What advice would you give to the other engineers looking into undertaking similar projects in terms of tool selection or data management strategies?
I guess now you can use Shiny for Python. So if the data is being generated or received in Python, then you can directly use that. But I guess Redis is something very useful here. Recently, unfortunately, they changed their policy for usage. I'm not 100% sure what that entails, but there are multiple forks of Redis now. So you can still use the functionality, but you need to look into the documentation. But I think Redis is something very useful. It could possibly be useful when you are reading data behind the scenes in multiple R processes. I know there are other packages that are used for that, but I think Redis could be incredibly useful if you want to connect multiple languages.
Thank you. Thank you, Mayur. Thank you for your presentation and joining the conference. And I see you guys in 10 minutes. Please take a break and we'll resume shortly.